Hello everybody, and welcome to project 2 of my engineering project series. And in this video I'll be going over my biometric chest, and I'll be going over the circuit, the process of enrolling a fingerprint, the CADing with the project, as well as the assembly and the final product. So with that, let's get into the video. So here are the parts. So first we have the Arduino Uno microcontroller. The Arduino Uno adapter cable, the high let go PC89685 motor driver, a digital servo motor that has 20 kg of torque, an optical Mega 2560 Arduino Uno fingerprint sensor, a micro RGB light, 3 220 ohm resistors for the RGB light, a 5-volt external battery power source, a breadboard, 4 pin-to-hold jumper wires, 10 pin-to-pin jumper wires. And now let's go through the process of enrolling a fingerprint. And so to do this, first I would recommend grabbing the code that I put in the description that's custom made by the company who made the fingerprint sensor, that's specifically for enrolling the fingerprint. And all of this stuff is completely textbook when it comes to wiring. So I'll show you to do that now. So first we have our purple and green. Purple is 5V, green is ground. And so now we have our fingerprint sensor right here. And so now we'll grab first the red, connect that to 5V, and then grab black, connect that to ground. And then from here, all we have to do is grab green and white, and we can leave blue and yellow unconnected. And green connects to digital pin 2, and white connects to digital pin 3. And this is always going to be the same for everybody because this is specifically made by the company who made this fingerprint sensor. Alright, so now that I've connected everything, I'm about to plug in the USB cord. But before I do, first I'm going to pull up the serial monitor for what it's going to look like when I run the code, because it basically tells you exactly what to do. And so now I'm going to connect this. It might turn on, but then we're going to want to re-upload the code and then pull up the serial monitor. And so now you can see the serial monitor. It should be up on the screen. And now notice what happens. So it turns red. It's trying to enroll fingerprint. I put my thumb down, remove finger. And then now it wants me to place the same finger, because basically it's going to take two photos and then match them together. And now you can see ID1 is stored for my right thumb. And that's how you enroll fingerprint. And remember, this the wires are going to be exactly the same for when you connect it if you use the same sensors as me. And all the links for everything will be in the description. But anyway, now that we've enrolled our fingerprint into the fingerprint sensor, we can get into the main circuit of the project. Okay guys, so now that we've gone over and enrolled all of the fingerprints and have our test circuits, I've put together two main parts of the circuit, and then we're going to combine them in a second. So first we have this, which was exactly an exact replica of what we went over last time when enrolling a fingerprint. So the same thing with the blue and yellow wires still aren't used, and then it's connected to the digital 2 and 3 pins, and then ground and 5V just like last time. And now all we're going to do is just take a quick look at this circuit and then combine them together. So first we have our motor, and then our motor driver. So we have our motor right here, and it's connected to channel 0 of the motor driver. And then now we have our 5-volt external battery power source right here, and this is rechargeable. And everything, all the pieces in this circuit are linked in the description. But anyway, basically we grab that motor driver and we connect the 5V to this thing that says V plus on this side, and then we connect the ground to the other side. And anyway, that's about it for this circuit. So now we can go over and grab some of our hold jumper wires. And so first I'm going to connect the black and red wire like so, and then these wires are going to be the 5-volt basically, and the black. And you can see here ground is connected to the black wire, and then the VCC is connected to the red wire. And then I connect these two, to the ground and 5 voltage on the Arduino Uno. Okay, so now that I've done that, all I need to do from here is just connect the SDA to purple, and this is going to be the pin right next to the right over the red wire, and then I connect this to A4, and it is hard to see, but here you can see purple is right here, and this goes to A4, and then after I connect all the circuit and show a demonstration of it, I will be showing all of the code I wrote to create this. And then SCL, which is right next to SDA, is connected with a white wire, and this white wire is going to go to A5. So now once I've done that, we're ready to run this circuit. So I'm going to plug in the USB, and the code should already be uploaded. So now basically the main idea of this code is this motor acts as a opener for the chest. So for example, if the chest was here, it would go like this and close and or open the chest. And I'll show an example of this. So let's say the chest ceiling is like right here, and then it goes down to close the chest and then it goes back up. So now you can see an example of this here. So now I enrolled my right fingerprint, remember? So if I put my fingerprint here, and we just need to match, so I need to put it on. It might take 1 or 2 tries, because sometimes this fingerprint sensor could have trouble working, but eventually you can see it closes. And basically in my code that I wrote, I made it so it toggles on and off like so. And so anyway, that's a good demonstration of the circuit. So anyway, now we can get into the code, and then after we could start 3D modeling. Okay, so now that we've gone over the test circuit, now we can get into the code for the main circuit. So first we have our 2 libraries for the motor driver, 2 libraries for the fingerprint sensor, 1 for the servo. So to start off, we have our 3 servo parameters for the minimum and maximum the servo can handle for voltages and pulses in this motor driver. And then we have our servo channel, which is just 0. And now we have our motor driver initialization in its name. And now we have our 2 pins that are going to be helping with the fingerprint to scan and just transfer receive data. And now we have our fingerprint sensor initialization. Then we have our pins for the RGB LED, which I add in later. And it's just going to turn green basically if the fingerprint's correct and stay red if it's false. And then this initializes the servo min position. And then basically from here now we have our initialization for the serial, and we have our driver initialization for driver, servo confirmation, then initialization for the servo, and then all of this stuff is basically just for the initialization for everything. So you can see here the specific stuff I have to do for the fingerprint sensor, and all of this verifying stuff and making sure that the fingerprint sensor is connected, or else it wasn't connected. And then now we have our 3 pins for the RGB light, which is added in later. This is just the basic stuff. And then we initialize the color to red because the fingerprint sensor isn't scanned yet or anything. So now we have our main loop, and this is for checking if the fingerprint's detected. And then if the finger confidence is over 60, and that's just basically a metric that the fingerprint sensor uses to determine how likely it believes that the fingerprint provided to it is correct. And then if it is, basically you can see here how we set it to if the servo min position, and this is what keeps track of if it's at a certain which position the motor's at, and this is what allows us to do the toggle feature. And this is the main thing that I wrote. And then most of the other things are just like if-else statements for errors that are very specific for the fingerprint sensor. So anyway, you can see here if it's false, then it does the corresponding thing, and if it's true, it does the other corresponding thing, so either going up or down. And then now it would set the color to green if it's correct in this statement, and then else, then it's the fingerprint confidence is under 60, then it just stays red, or turns it red if it was green before. And then this turns on the red LED if no fingerprints detected, so it would just stay red, but I need to add that in anyway. And this is another specific case. And then right here we have our cases, which I took this from the company, and this is very specific cases, as you can see. And this is all just the cases for when you try to implement a fingerprint, when you try to scan a fingerprint and it's not correct, or there's like a communication error, imaging error, or any other type of error. All that stuff is very specific to the sensor, and this is all that stuff here. And then this is for after pictures you've taken. This is more test cases for see, you can see how we have image converted, image too messy, communication error, cannot find fingerprint features, so on. So anyway, now this last thing we have, if the print is a match, then it just does this and prints the fingerprint ID, and then it's confidence. So obviously it's gonna be over 60 because this wouldn't be ran if it wasn't. And then this just has a few more errors that are very specific to the fingerprint sensor, but which we still need to implement. And then now we have our function for setting the color. So we take our 3 parameters in, red, green, and blue, and then we analog our right 3 pins, and then serial.print, and then basically all of this stuff is printed with the corresponding RGB colors. And all this stuff is just in the serial monitor, and I don't really need to display this, but basically a lot of this stuff, there's a lot of information that's passed through the serial monitor to make sure that the fingerprint sensor is running smoothly. And then after all this code, that is what caused the main circuit to do what it did in the demo that I just showed. So anyway, that's about it for the code. So now we can get into the 3D modeling. So when starting this model off, I didn't really know what I was going for too much. I kind of just laid a sketch down and then went from there. But then as I started to model, I started to get a better idea of what I wanted to do. And then eventually I reached this. And so basically the main key feature of this is the fingerprint sensor hole, which I'd use a protractor for to figure out the angle of which the fingerprint sensor could line up to be parallel with the top of the chest. And then we have the wide back of the top of the chest to mount the top. And then I also did design a top for the chest right here. And right here you see we have the motor handle mold that connects to it that I could epoxy on. And then we have the fillet in the back so that it could go up and down smoothly without any sort of problems with the top running into the base. And so anyway, with that, that's about it for the 3D model. And so now we can get into the 3D printing and then assembly. So now that the parts are printed, here's what we got. And then finally, after putting the circuit together, enrolling the fingerprint into the fingerprint sensor, catting out everything and 3D printing the custom pieces, I epoxied the motor and fingerprint sensor to the base, then epoxied the top of the chest to the motor, and then connected up the circuit to the Arduino. And this is how I got this. More videos coming soon.